Sophie Germain was a French mathematician who worked a lot with number theory. Here we're going to look at an activity where you can find out how many factors a number has, also known as divisors, by looking at the number factored down into its primes and then its prime factorization. So let's look at this chart here. So if you look at the chart, we have the number 1, or number 2 rather, and you know that the factors of 2 are 2 times 1, and if you were to write 2 times 1 as prime factors, like if you were to do a factor tree of 2, you would just get 2. So 2 is 2 to the first power, and then I see that I have 2 divisors. Okay, 3 works the same way. 3 is 3 times 1. The prime factorization of 3 is 3 to the first, and here I have, again, 2 divisors. So let's look at 4. 4 we know is a square number, so since square numbers have an odd number of factors because we don't ever count that double one, let's look at how we might do this. So we've got 4 is 1 times 4 and 2 times 2, which gives me a total of 1, 2, 3 factors. And if I do it as a prime factorization, 4 of course is 2 to the second power. Let's skip down a little bit and let's go to 10. So 10 is 1 times 10 and 2 times 5, which gives me a total of 4 divisors. The prime factorization of 10 is 2 to the 2 and 5. And then the last one we're going to do is 24. Remember, 24 is an abundant number, so 24 has a whole bunch of factors. 24 is 1 times 24, 2 times 12, 3 times 8, and 4 times 6. So that's 1, 2, 3, 4, 5, 6, 7, 8 factors. So there are 8 factors of 24. So if I look at my factors of 24, and I do the prime factorization of 24, 24 is 2 to the third power, which is 8 times 3. So what I want you to do right now is I want you to look at the exponents and see if you can't figure out how we're getting from these numbers that I've circled up to the 8. So the last one that I'm going to look at is 10. So I've got 10, I've got 1 and 1 and 10 and 2 and 5. That gives me 4 factors. And here I've got these exponents of 2, and 2 give me 4. So 2 gives me 4, 4 gives me 8, but here 3 gives me 4, so that doesn't work. So see if you can't think about it, and pause the video and I'll tell you what the answer is in a sec. So pause. So what Germain figured out was that if you took any number and you looked at it, like let's say 16. So 16 is 1 times 16, 2 times 8, and 4 times 4. If we do the prime factorization of 16, that is 8 times 2, and then this is 4 times 2, and then this is 2 times 2. So 16 is 2 to the 4th power. 16 has 1, 2, 3, 4, 5 unique factors, or divisors. So what she found was if you took the exponent of the prime factorization and added 1 to it, you would get how many divisors a number has. But if you had a number that had 2 prime factors, for example, 144, and 144 is 2 to the 4th times 3 to the 2nd, she added 1 to each exponent, and then she found that this number had 15 divisors. So what did she do to get the 15?